All right, the first concept in this next unit, Unit 7, and the unit is called the mole, or the molar concept. And the first concept in here is just to understand what the mole is. The mole is a quantity of measurement, just like a dozen is to a baker. So a dozen represents a larger quantity of substance like a donut. It represents 12 donuts for every dozen. So it represents a larger quantity than just a single one. Same thing for a chemist. In a chemist, the mole, indicates 6.02 times 10 to the 23rd. So 1 mole, 1 mole equals 6.02 times 10 to the 23rd. And we call this number is called Avogadro's number, after an Italian scientist that was looking at ratio of gases and determined the number of particles in a mole, in a quantity. So Avogadro's number is 6.02 times 10 to the 23rd. It is on your chem helper, all right? And it's something that you can easily look up and utilize. So we can create a conversion factor for that, in which 6.02 times 10 to the 23rd, and then whatever the label is on it, let's say it's an element, atoms, are equivalent or equal to 1 mole. Or I could put 1 mole on top and Avogadro's number on the bottom. But this becomes a conversion factor, and so this unit is going to utilize a lot of that stuff back from Unit 1, where I told you specifically to make sure you get really good at factor label method, because you're going to use it again. And this is where we're going to lead to it, and that is being able to use these different conversion factors to be able to change the units on these numbers. One side note, if you are talking about an element, a monatomic element, like zinc, there are 7 diatomic elements. All the other elements are considered monatomic. So 1 mole of a monatomic element is 6.02 times 10 to the 23rd atoms. If you have a covalent compound, the simplest particle of H2O would be a single H2O particle like this, and we would call this a molecule. So when I have a mole of water, I have a mole of these guys, and I don't say I have a mole of atoms, I say I have a mole of molecules, because the smallest particle of water is called a molecule. If it's an ionic compound, we're held together by ionic bonds, we don't say molecules, we say formula units. So again, a formula unit is just like a molecule. The difference is we're looking at a covalent bond versus an ionic bond. But in essence, they mean the same thing. It's the smallest unit of measurement of an ionic compound. So you've always got to first make the distinction as to what the substance is and what its smallest particle is. If it's an element, a monatomic element, then it's atoms. If it's one of the diatomic elements like oxygen always occurs as O2. We would say that this 1 mole of O2 would possess 6.02 times 10 to the 23rd molecules, because there's a bond there, so it's not an atom but a molecule. So for the diatomic elements, which again is on your chem helper, it's to the right of where it says chemist try. 1 mole of any of the diatomic elements would be 6.02 times 10 to the 23rd molecules. Now where did they come up with this number? Well, they determined that if you had pure carbon-12, so again, carbon has 3 naturally occurring isotopes: carbon-12, carbon-13, carbon-14. Carbon-13 and 14 have the same number of protons. They have just different weights because they have different number of neutrons. But if we were to get just pure carbon-12, if we just have pure carbon-12, they determined that this was the number of particles that it took to equal 12 grams. Or also the fact that carbon-12 has an atomic weight of 12 AMU. Atomic mass units. Carbon-12 weighs 12 because it contains 6 protons and 6 neutrons. So with that, it was also the number of particles that it took for the number of carbon-12 atoms to equal 12 grams. It took that many particles to get a large enough amount of carbon mass that the molar mass, the mass of 1 mole of the compound, would equal its atomic weight, which would be the mass of 1 atom of it. And that's how they determined Avogadro's number. So if you look up the element hydrogen, hydrogen on the periodic table has an atomic weight of 1.01. This is the average mass of 1 atom of hydrogen, and the units on that are AMU. But if I have a mole of hydrogen atoms, 6.02 times 10 to the 23rd, those guys have a total mass of 1.01 grams. Okay, just like one donut might weigh 1 ounce, 12 of them will weigh 12 ounces. Okay, so with that, the mass of one atom is AMU, the mass of a mole of atoms, or 6.0223, is 1.01 grams. Nitrogen is 14.01 AMU, therefore 1 mole of nitrogen weighs 14.01 grams. And I would just continue looking up each of the elements. And therefore a mole is the same number, but now instead of AMUs, we have a large amount of material that we can measure that in grams and use a balance here in our chemistry station. All right, I'm going to pause the lecture now. What I'd like you to do is to try to complete the table in the bottom here. Complete this table and see what you get for the values. And then when you start the lecture up, I'll have all of the values imported, and then I'll briefly talk about them. But please stop the lecture now and try to fill it out before you continue on with the lecture. All right, all these values, when you're looking up these elements, you should have hopefully been using the periodic table and seeing what each of these elements are. And again, when you have 1 mole of that substance, the mass on the periodic table matches the mass of the compound. The difference is, instead of being AMU, it's grams, because it's a large quantity of material. It's a mole quantity. And therefore, we get these same numbers that pop up, the 6.02 to the 23rd. It wasn't until you get down to carbon that hopefully you notice that the number 3.01 to the 23rd is exactly 1/2 of Avogadro's number. So instead of having 1 mole, we have 1/2 of a mole. And therefore, instead of having 12 grams, which is the mass of 1 mole, it would be 6. It'd be 1/2 of 12, which is 6. Potassium has an atomic weight of 39.1. So it being 78.2, you should have recognized as double that, and therefore instead of having 1 mole, we have 2 moles, and therefore we have to double Avogadro's number, because we don't have 1 mole, we have twice the number of moles, and we get 1.2 to the 24th. Whenever we have a compound like carbon dioxide, the critical thing is to figure out its chemical formula and to add up all of the elements, and the mass of 1 carbon and 2 oxygens adds up to 44.01. This would be then the mass of 1 mole of the compound. Okay, so I'll say that again. This is the mass of 1 mole of the compound. And again, because it's still 1 mole, it doesn't matter if it's an atom, an element, or if a compound. If you have 1 mole of something, you have this many particles. But instead of being number of atoms, it's actually the number of molecules. Okay, it's the number of CO2 molecules, just not atoms. But the mass of 1 mole of something is called the molar mass, which is what we're going to do next. So to find the molar mass of the compound, we just simply have to add up the masses of all of the elements of the chemical formula. And again, if I measure that amount of mass, I have 1 mole present in that mass, and that also tells me I've got 6.02 to the 23rd number of particles, molecules or atoms or formula units of that compound as well. Okay? All right, so let's turn the page. So as I said, molar mass is defined as the mass of 1 mole of the compound. And we very simply get it by adding up all of the masses of all the elements. So number 1, we have water. So the first step is you got to figure out the chemical formula of water, which all of you should know is H2O. So when we do a molar mass problem, what we're going to do, and I typically tell students, and again, this is a pretty easy one, but when they get harder, write down all of the elements that you have. This is the process that I would do. And again, on the test or on the quiz for this unit, you must show your work. If you do not show the work that I'm going to show now, you will not receive full credit for the answer. Even if your answer is right, I will take off for not showing your work. You must show work. So for those of you that like to be lazy, this is not a time to be lazy. So I look up the mass of hydrogen, which is 1.01, and the mass of oxygen in the periodic table is 16.00. Multiply across, and this is the mass coming from each of the elements, and the final step in a molar mass problem is 18.02. This is the mass of 1 mole of water. So if I have 6.02 times 10 to the 23rd molecules of water, that it would have a weight of 18.02 grams. That is the molar mass of water. And it's something that very quickly you're going to memorize because you're going to see it so often. Okay? If you wanted to know the mass of one molecule of water, how much does one molecule of water weigh? It weighs 18.02 AMU, atomic mass units. So again, 1 mole of something is the gram quantity on the periodic table. 1 molecule, or the smallest unit of, or an atom of a monatomic element, is that same number, but in units of AMU. So that is the distinction, is the units, okay? But it's the same number. All right, I'm going to pause the lecture again. I'd like you to go ahead and try to do numbers 2 and 3. So pause my lecture. Go ahead and do this on a sheet of paper. And then when you restart the lecture, I will have the answers supplied for you. All right, the answers here, as you can see, very common for calcium hydroxide for students, especially with the oxygen, not to distribute the 2. The 2 is distributed both oxygen and hydrogen, so you have 2 of each. Sometimes students will only do that to the hydrogen. So then you can see my math and you get a total of 74.10. One thing I forgot to mention before I pause the lecture is the units. The units on molar mass. Units are very important. If you don't have the proper units, you might be docked points here on the test. The units for calcium hydroxide, if it's molar mass, the units are grams per mole. 1 formula unit, or 1 particle. So if I have 1 calcium hydroxide, so that'd be a positive 2 calcium, and you've got 2 hydroxide ions attached to it. This is called a formula unit. 1 formula unit of that has a same weight of 74.10, but again, because it's just 1 of the particle at the lowest level, that would be 74.10 AMU, atomic mass units. And again, 1 proton and 1 neutron have about 1 atomic mass units. So 74.1 is really almost the entire total number of protons and neutrons of all these elements added together. Okay. Dinitrogen pentoxide, formula N2O5. Okay, multiply across 2 nitrogens, 28.02, and 5 oxygens, 80, for a total mass of 108.02 grams per mole. Again, this is the units on molar mass, is grams per mole. There are 108.02 grams of dinitrogen pentoxide in every mole of it. 1 molecule of N2O5 has an atomic weight of 108.02 AMU. All right, so that's the first initial concept on moles and molar mass. Your homework for this, after this first lecture, is page 3 in your packet, right here. So please complete this page, and I will have the answer key supplied in Canvas, and then you can check your work. The end of this week, there will be a quiz that becomes available on these concepts, and the quiz is not multiple choice. It's going to be a lot like this, where you have to complete questions and you have to show your work. So it's something that most students find usually easy if they've done the practice. My worry is you being at home, that you won't do the practice that you really need to do. So please make sure that you do that. And the quiz, you have to show your work along with your final answer with proper units to get full credit. Okay, so that's what the quizzes will look like along with the test in these next couple of weeks.